let's discuss how a new node can be inserted before a given node. In the previous video, we discussed how a new node can be inserted after a desired node, but here in this video, we are going to discuss how a new node can be inserted before a desired node. Let's take one example as usual, one singly linked list structure with 4 nodes. Addresses are AA, BB, CC and DD, and the data elements are 5, 10, 15 and 20. So if I write BB here means these two will be connected, CC so these two will be connected, I am writing DD here so these two will be connected. Always the last node's next field will be having null and the first node's address will be stored under the start variable, which is AA. So this is the list. Now I want to insert a number 30 before a desired node. Let's take an example. My desired node is here 15. So before 15 here I want to insert a new node, that is 30. So new node will be created as a very first step. New node will be created. Once the new node is created, in the place of new nodes data field you can write the number which you want to insert. Okay, the actual information, the data information is stored here in the place of new nodes data field. Now the next step is finally our task is going to be you have to disconnect this link, and since before this 15 you want to insert this 30, after inserting the new node 30 you have to enable a connection between BB and new node, and also again you have to enable a connection between new node and CC. So when this can be done, when you exchange the addresses of these two nodes next field, these two connections will be enabled, right? So let's see how these two connections will be enabled. The very first step is we are supposed to identify the desired node. Before desired node only this new node can be inserted. So to identify the desired node, since the random access is not allowed here in the linked list, only the data can be accessed in a sequential manner, we are supposed to start from right from the first node until you reach the desired node. You are supposed to keep on incrementing the pointer. So here again I am going to increment 2 pointers here. One is pointer will be initialized with the start, and next is pre-pointer, and this will be initialized with the pointer. So later you will understand like why 2 pointers are used here, because in the previous case after a given node only 1 pointer were used, but here we are using 2 pointer. At the end of the lecture you will understand why 2 pointers are used, why pre-pointer we have used here. The condition should be as usual, find the desired node. So to find the desired node the condition should be while pointers data field is not equal to value, the desired node value. The desired node is what? 15. Before 15 only I want to insert a new node 30, right? So if the pointers data field is not 15, of course you can keep on traversing the pointer equal to pointers next. So here I have initialized the pointer with the start, so my pointer will be pointing the starting node. Again pre-pointer is initialized with the pointer, so both the pointer as well as the pre-pointer will be pointing the first node. Now the condition is check pointers data field is not equal to null. Pointers data field is 5, here it is 15, which is not equal to 15 only. If so, you can increment the pointer. So before you increment the pointer, before you increment the pointer, because we have used 2 pointers here, so what you do, place your pre-pointer at the current pointer's location and then you increment your pointer. pointer equal to pointers next. So pre-pointer will remain in the same position because pre-pointer we are supposed to place at the pointer's position, and pointer alone we are supposed to increment. Pointer equal to pointer next. I have incremented the pointer. So now my pointer is pointing to the node BB. Check for the condition again. Pointer's data is not equal to value. Yes, pointer's data is not equal to value only. The value here is 15. My pointer's data is 10, which is not equal only. So the condition is again getting satisfied, right? So the next step should be you just make pointer as a pre-pointer and increment the pointer to its next position. So now my pre-pointer will come here and pointer will go there, right? So pre-pointer is pointing to the node BB and the pointer is pointing to the node CC. Again, check for the condition. Pointer's data is not equal to value. No, it is equal to value. The condition is not getting satisfied. If so, it has to come out of loop. Now pointer is pointing CC, pre-pointer is pointing to the node BB. Now the next step is exchanging the addresses of these two next fields, right? So first we are going to enable the connection of these two nodes, new node and CC. So what should be placed in new nodes next field? If I place the address of CC, these two nodes will be connected here at the place of new nodes next field. These two nodes will be connected, right? So where is the address of CC? Either you can directly, since my pointer is pointing to the node CC, either I can write pointer directly, or otherwise in the place of new nodes next field you can write this line as well. The CC is placed at where? Pre-pointer's next field, right? You can write it like this, pre-pointer next. In both the places there is CC only, right? So after executing this line, CC will come. After writing CC here, these two nodes will be strongly connected, right? Now again, you are supposed to enable this connection now, right? So when this connection will be enabled? When you write the address of new node in this place, in the place of pre-pointer's next field, these two will be connected, right? The BB and new node will be strongly connected, right? So in the place of pre-pointer next, if you place new node's address, these two will be strongly connected and this connection will be disenabled, right? Now the complete list is ready, right? So here I have placed new node's address, so these two were connected, and then again in the place of new node's next field I placed the address of CC, then only the new node and the node CC will be strongly connected, right? Now the complete list is ready. So inserting new node before a decision node, which is 15, is done now. Then exit. So now the complete list is ready. So this is the algorithm for performing insertion before a given node in a single linked list. Thank you.